Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of identifying functions. This is standard 8.5G in the great state of Texas, and we are using item number 5 off the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have 4 different graphs. All we have to do is identify which one has y as a function of x, but there's no definition of what a function is. It's not on the mathematics chart as well. So that is something we definitely have to come into this problem knowing. So let's do that real quick. What is a function? So a function is any relationship here. And in this case, we've got it on graph. We can also map it. We can also just view sets of ordered pairs. We can even put it in a table where we have one input leading to one output. So what does that mean for us? Well, our input is always going to be our independent variable. And so if our input is our independent variable, that means our output is going to be our dependent variable. And we have already kind of used those for years. There's our independent variable being our x. So we start with x, we multiply it, we divide it, we add to it, we put it in order of operations, we use exponents, even square roots. We do something with x, we end up with our dependent variable, which we represent with y. So that's basically what we're looking at, is 1x always leads to just 1y. Okay, so let's see if we can do that here. So I'm just going to use the major points here, right? So I've got 0, -1, all right? And then if I were to do that point right there, I can see I've got 2, -1. Actually, it looks like all of it's going to be -1. It's a straight line. So -2, -1. So if I were to look at those points, could I find any instance in which 1x leads to more than 1y? And no, it looks like no matter what my x is, I cannot find another x that leads to that same y. Remember, I need one x that goes to one y. So that could be it. Now, every single y is the same. It's all -1, but that's fine, because each time we get to that -1, we're using a different x. What we don't want is we don't want two y's going back to the same x. All right, so let's look at B here. So it looks as if we might be fine here, right? Almost. Oh, but you know what? Look at this. We spoke too soon. Take a look at this -2. It's almost -1. Let's call that -2, -1. But look at this right here. It's a little bit past -4, but we'll just call it -4. Look at that. I've got 2 different y's coming out of that same x. So 1x, excuse me, leads to 2 different y's. That's not going to work. This definitely not going to work, right? I've got 0, -3, and I've got 0, 3. So I've got 1x, 0 leading to 2 different y's, and this whole thing is just x of 2, and all the y's stay the same. Easy way to always look at graphs is if you can just perform a vertical line test. So if you can draw a vertical line, and as long as it doesn't hit the graph twice, you're good to go. So A looks good. You see you got a problem there with B right there and there. You got problems all over C. My vertical line is hitting the graph twice, and the whole thing is a vertical line. So my answer here is A.